Assalamu alaikum everyone. Welcome back to Chemical Compass, your guide to the world of chemistry. In today's lesson, we are diving into some fundamental concepts that will help you understand the structure of atoms even better. We are talking about atomic number, atomic masses, element symbols, and the important trends in the periodic table. Plus, we will explore how these concepts show up in real world applications. Let's get started. First up, let's talk about two key properties that define every element on the periodic table: atomic number and atomic mass. Atomic number. This is the number of protons in an atom's nucleus. The atomic number is crucial because it determines the identity of an element. For example, if an atom has 6 protons, it's carbon, no question about it. Every element has its own unique atomic number, and that's how we classify them on the table. Next point is atomic mass. This is a little trickier. Atomic mass is the average mass of an element's atom, which accounts for the different isotopes of that element. Isotopes are versions of an element that have the same number of protons but different numbers of neutrons, giving them slightly different masses. So the atomic mass we see on the periodic table is an average based on the abundance of each isotope. Here's a helpful tip. You will always find the atomic number at the top of each element's box in the periodic table, while the atomic mass is usually listed just below it. Next up, let's look at the element symbol. That one or two letter abbreviations that's unique to each element. You have probably seen symbols like O for oxygen or H for hydrogen. These symbols just these are more than just shorthand, though they come from the element's name often derived from Latin or Greek. For example, oxygen comes from the Greek word oxygen, meaning acid former. Iron comes from the Latin word ferrum. So when you see an element symbol, there's usually an interesting story behind it, and it's a reminder of the history and language that shaped chemistry. Now let's talk about some of the fascinating trends you can spot in the periodic table. These trends help us predict the behavior of elements based on where they are located on the table. Our first point is atomic radius. This is basically the size of an atom, and it changes depending on where the element is. As you move across a period, the atomic radius decreases. The reason behind this is as more protons are added to the nucleus, the pull on the electrons increases, drawing them closer to the center. But as you move down a group, the atomic radius increases. That's because the electrons are being added to new electron shells, which are farther from the nucleus. Our next point is ionization energy. This is the energy required to remove an electron from an atom. As you move across a period, ionization energy increases. The more protons in the nucleus, the harder it is to remove an electron because the attraction is stronger. But as you move down a group, ionization energy decreases. The electrons are farther from the nucleus and feel less attraction, so it's easier to remove them. Moving to the next point, electronegativity. This is an atom's ability to attract electrons in a chemical bond, similar to ionization energy. Electronegativity increases across a period and decreases down a group. Elements with high electronegativity like fluorine and oxygen really want electrons and are great at pulling them in when they form bonds. So why do all these atomic properties matter in real world? Well, understanding the periodic table can help us predict how elements will behave in various situations. Let's look at example, chemical behavior. By knowing an element's position on periodic table, we can predict how it will interact with other elements. For example, elements in the same group like the alkali metals tend to react in similar ways. They all form salts with halogen, like sodium forming sodium chloride with chlorine. Our next point is medicine. Elements also play crucial roles in our health. Iodine, for instance, is essential for thyroid function, and iron is key in our blood to help carry oxygen. Understanding these elements helps in developing life-saving treatment. Moving to the next point, technology. In the world of technology, rare earth elements like lanthanum and neodymium are essential in electronics like smartphones, computers, and even electric cars. Without these elements, much of the modern technology we rely on wouldn't be possible. And now for some fun and surprising facts about the periodic table. Over 100 elements, there are currently 118 confirmed elements. Some of them are super rare and others are man-made in labs. But all of them contribute to our understanding of chemistry and the universe. Talking about most abundant elements, the most abundant elements in the universe is hydrogen. It makes up around 75% of all normal matter in the universe and is the fuel for stars, including our very own sun. And the next point is elements named after places. Some elements have cool names that other countries or places where they were discovered, such as francium named after France, americium named after the America, Poland in the honor of Marie Curie, californium after California, and even Einsteinium after great scientific minds and institutions. Chemistry is full of history, and the periodic table is a testament to that. Let's wrap up today's lesson as atomic number, atomic mass, element symbols, and some key trends in the periodic table. We hope this helped you see the connections between these concepts and their real world application. If you enjoyed the video, don't forget to like, subscribe, and click the bell icon so you won't miss out our next lesson. We will be diving into even more exciting chemistry concepts.